Hello guys. So we have a new good question of maxima minima in which the area and perimeters are included. So in these plane figures, 2D figures, this is a good question. So according to this question, we have a wire of length 25 centimeter. It is just like we have a wire of total length is 25 centimeter, right? So according to question, we will cut into two pieces. Let us consider first is this part, its length is x, and the length of this part is 25 minus x. Right. Right now is saying that one of the wire is bent into a square. So AC, the part AC will convert into a square whose total length is x, and the part BC is forming a circle. So part AC is converted into square and part BC is converted into a circle. So according to this, we have a circle as BC. So the circumference of this circle is 25 minus x. We mold this into a circle, and the length of AC equals to the circumference of this square. Let us consider its length is P is a square and its radius is Q. So 4P equals to the circumference of square, it is 4x, 4P equals to this length x. So P equals to, P is the side of this square, we get P equals to x by 4. And the second information about the circle, the circumference, it is 2 pi q is 25 minus x. So q equals to 1 over 2 pi 25 minus x. This is the radius of circle. So our proving condition is combined area of square and circle. So according to this, area, combined area of square plus area of circle. So it means it is side square, that is P square, and it is pi q square. So right now we can put the values of P and Q in this expression. So the area expression A equals to P square, P is x by 4, and pi q square, q is 25 minus x over 2 pi, and the squaring this. So P is x by 4 and q is 25 minus x over 2 pi. So we put these values. So right now this is the area expression on which we will apply second derivative test. So according to second derivative test, first we will differentiate it and we will get the first derivative. So it will be 2x over 16 plus twice of 25 minus x into minus 1. So you get 2x over 8 plus you get minus 25 minus x over 2 pi. So this is the first derivative. Now we put d over dx equals to 0. So it is x over 8 minus 25 minus x over 2 pi equals to 0. So x over 8 equals to 25 minus x over 2 pi. So we want to collect the values of x. So right now so it is pi x and this is 100 minus 4x. So there is x is in common, so you get pi plus 4 into x is 100. So x is 100 over pi plus 4. So this is the first part of that wire, that is AC. Now we want the second part. So second part of the wire, that is BC. That is 25 minus x. So it will be 25 minus 100 over pi plus 4. So on taking LCM, pi plus 4, we get 25 pi plus 100 minus 100. So cancel out, we get 25 pi over pi plus 4. So it is the length of second part which is converted into a circle, and this is the square. It is first part, that is AC. So these are the length of this wire. Now this sum should be least. Right now we will differentiate it. So we have dA over dx is x over 8 minus 25 minus x over 2 pi. So on taking one more time differentiation, so we get 1 over 8 and this is minus 1 over 2 pi. So this becomes 1 over 8 plus 1 over 2 pi. So it is positive term. So the second derivative of area expression is positive or greater than 0. So it shows the combined area of these two figures is least, minima. Now the next question, we have two resistors R1 and R2, and these are combined in parallel system. These are attached with parallel system. So just like we have R1 and R2. And the equivalent resistance of this is R. So that is R value, and in case of parallel system the relation is 1 over R is 1 over R1 plus 1 over R2, and it is given the values of R1 R2 are positive, and if R1 plus R2 is the summation of these two is constant. So show that the maximum resistance is obtained by choosing R1 equals to R2. So show that the maximum resistance, that is R, is obtained by choosing R1 equals to R2, means both should be equal. We have a given condition. This is the given condition. This is the proving condition, and it is intermediate condition. So we will start with given condition. So we have R1 plus R2 equals to C. So the value of R2 will be C minus R1, where it's C is constant. Now put this value in the proving condition, and proving condition is this. So 1 over R equals to 1 over R1 plus 1 over R2. On taking LCM, and putting this value according to this, so it is C R1 R2. So R equals to R1 into R2 over C. So we can say it is 1 over C R1, and what is the value of R2? So put it here, that is C minus R1. So this is the proving condition on which we will apply second derivative test. Equivalent resistance R, that is 1 over C R1 and C minus R1. So on applying second derivative test, we will differentiate the equivalent resistance with respect to R1. So 1 over C is in common, and applying the product rule, so R1 is 1 and C minus R1 as it is, plus R1 as it is, and there will be minus 1. So it will be 1 over C, and there is C minus R1 minus R1. So it is 1 over C minus 2R1. This is the value of first derivative of equivalent resistance. Now we will collect the second derivative, that is 1 over C, and there is 0 minus 2. So we get minus 2 by C, or you can say negative. So it means the second derivative is negative. or you can say less than 0. So it shows the maximum resistance right now. And for intermediate condition, we will put dr over dr1 is 0, so it is 1 over c minus 2r1 equals to 0. It means c minus 2r1 equals to 0. So 2r1 equals to c, and r1 is c by 2. So this is the value of first resistance, and the value of, because we know r1 plus r2 equals to c, and value of r1 is c by 2. So r2 is c minus r1, so it is c minus c by 2. Again we get c by 2. So the value of r1 and r2 both are equal, and when these values are equal, then if we apply these, we combine these two resistors in parallel system, then the resistance will be maximum.